Hi, welcome to the last video from Chapter 4, Section 4.6, the Trapezoidal Rule. It's one formula, that's it, that's all. Okay, so before we were dealing with Riemann sums, which is approximating the area or the definite integral by using rectangles, either left endpoint, right endpoint, midpoint, inscribed, circumscribed, and they will tell you which one. Now, instead of using rectangles, we're going to use trapezoids. This is called numerical integration. Because you're approximating. So Riemann sums is also numerical integration. So approximate the area or the definite integral using trapezoids. And that's called the trapezoidal rule. Now, first of all, let's talk about the formula for the area of a trapezoid, which is a little bit more involved than the area of a rectangle. So if you remember, the formula for the area of a trapezoid is 1/2 the height of the trapezoid times the sum of the bases. Now, the bases are the two parallel sides. And the height, of course, is the vertical distance between the two bases, which I could take anywhere. And some people memorize this without realizing all it is the sum of the areas of two triangles that happen to have the same height. If I take this triangle down here, I can use B2 as the base and H as the height. If I take this red triangle right here, then this is my base. And this is my height, which is the same height as I have over there. So I'm basically just factoring out the 1/2 h because they both have the same height and it's the sum of the bases. Okay, so here's what happens. Let's say we have this blue shaded area bounded by the curve y equals f of x, the x-axis, x equals a and x equals b. And what we're going to do is divide it into 1, 2, 3, 4, 5, 6 trapezoids of equal width, okay? So you'll be told what the function is and what the borders are, and I'm going to pretend this time it's x equals 1 to x equals 13. You'll be told to use a trapezoidal rule. You'll be told how many trapezoids, and if they don't state it, it means they're of equal width. Now, the interesting thing is the equal width here. What we're doing is our trapezoids are sideways. Our parallel bases are now vertical, and our height is actually our dx. So what it becomes for the area of any one of these green trapezoids is 1/2 its height, which is actually dx. And the sum of the bases is actually the y-coordinates of these heights, these altitudes. So what we figure out first is what is delta x, which is the famous b minus a over n, which in our case is 13 minus 1 divided by 6, which is 2. So you're starting at 1, you're going to go 2 to the right, then you're at 3, then 2 to the right, 2 to the right, 2 to the right, 2 to the right, 2 to the right. Now, from each one of these, go up to the curve itself. And once you've gone up to the curve, join those two green points. Go up to the curve, join the two green points. Now you'll notice some of the trapezoids are above the blue shaded area, others happen to be below. Whatever, it's an approximation. So here's what happens. So the area under the curve, which in this case, because the curve is above the x-axis the whole time, is the integral from 1 to 13 of f of x dx, is approximately equal to, that's very crucial, not equal to, but approximately equal to. And of course, now comes our formula, 1/2 the height, which is 2, in our case, our delta x, our height, times the sum of the bases. Now here's what happens. In the first trapezoid, your first height or base of your trapezoid is f of 1, and your second base is f of 2. F of 3. But then in the next trapezoid, you use f of 3 again and f of 5. But in the next trapezoid, you use f of 5 again. So what happens is, not the first or the last heights, or bases if you wish, but all the others in between get used twice. They get used for the trapezoid on the left and for the trapezoid on the right. So you have 1 f of 1, but you end up with 2 f of 3 plus 2 f of 5, etc., plus 2 f of 11 plus 1 f of 13. So here's the formula. It's called T for trapezoidal rule is 1/2 the height, which is b minus a over n. The books tend to write this as b minus a over 2n. I kind of like to keep it as 1/2 the height, which is your delta x. And then it's 1 times f of x0 plus 2 times f of x1 plus 2 times f of x2, etc. The very last one will be 1, but all the others in between are going to be 2's. And to get from each x value to each next x value, you're going to add delta x, which in our case was 2 each time. So it's 1 plus 2 is 3 plus 2 is 5 plus 2, etc. Okay, that's it. So if you look at page 316, by the way, there is something else in this chapter called Simpson's Rule. You don't need to know Simpson's Rule, okay? So on page 316, we are looking at numbers 1 through 10. So these questions right here, use the trapezoidal rule, forget the part where it says use Simpson's rule, to approximate, obviously, that's what the trapezoidal rule does, the value of the definite integral for the given value of n. N will be the number of trapezoids. Round your answer to 4 decimal places, compare the results with the exact value of the definite integral. Okay? All right. So if you look at number 6, approximate the integral from 0 to 8 of the cubed root of x dx. And of course, that is above the x-axis the whole time between 0 and 8. Using the trapezoidal rule, and this was with n equals 8, which is 8 trapezoids. So our delta x, which is our height, is our b minus a over n, which is 8 minus 0 over 8, which is 1. So it will be 1/2 the height, which is our delta x, which is 1, times 1 times f of our lower limit of integration, which is 0, plus 2 plus 2 plus 2, times, and then all you do to get from one to the other is just add that 1, because that's what we're doing. We're adding delta x, and then 1 plus 1 is 2. And you'll keep doing that until you get to the last one, and the last one will have a 1. So remember, starts with a 1, ends with the 1, all the others are 2's. And of course, what is f of 0, what is f of 1, our f of x is the cubed root of x. So the cubed root of 0, the cubed root of 1, cubed root of 2, 3, 4, 5, 6, 7, and the cubed root of 8 is that. And you will get that. If you actually integrate this, you'll get 12. You could do it by hand. It's not that hard to do by hand. And 11.7 is a pretty darn good approximation. And we only used 8 trapezoids. Now, the AP is more likely to do something like this, which is to give you a table. Do only with the trapezoidal rule. So let's look at those directions. Again, it's because it says and Simpson's rule. So approximate the definite integral using the trapezoidal rule with n equals 4 for all of them. Compare these results with the approximation of the integral using a graphing utility. So here you were able to find them by hand. Here they're very ugly, so you'd have to use a calculator to actually do them. All right, now, however, when you get to number 52, which is the one we're doing, let me actually draw a line here so that you understand these two have nothing to do with each other, okay? Okay, so that's pretty straightforward. Okay, now let's look at number 52. So when you're looking at number 52, you have the following, okay? So here's the graph for number 52. And here's the table for number 52. It's like a double table. Use the trapezoidal rule to estimate the number of square meters of land in a lot where x and y are measured in meters. The land is bounded by a stream right here and 2 straight roads that meet at right angles. So these are your 2 roads. So we're trying to approximate the area under this curve, but we don't have a function this time. All we have is a table of data. Now the first thing to notice is that your x's start at 0, end at 1,000, and are going up by 100 each time. So they are equally spaced trapezoids, okay? And that's all we need, because now we wrote the table here. So what happens is your delta x, which you can tell is 100, you know is b minus a over n. You know your b is 1,000, your a is 0. So that allows you to find out that there are actually 10 trapezoids. Now you could probably count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can actually count them. Okay, so what happens is the area will equal the integral from 0 to 1,000 of f of x dx, but that, using the trapezoidal rule, is approximately equal to 1/2 the height, which is dx, which is our 100, times f of 0 plus 2 times f of 100 plus 2 times f of 200. Basically, these are the x values you're using. 1 times f of 0, 2 times f of 100, plus 2 times f of 200, etc., plus 2 times f of 800, plus 2 times f of 900, plus 1 times f of 1,000. And of course, you have the values of f of each one of these. You just pull them out of the table, and you'll get 89,250 square meters. So recap of the trapezoidal rule. Once again, this is just a nicer version, and the middle ones get used twice. And here's another one. And this is the killer part, is this part right here. Let me actually underline that in, let's do that in purple, okay? So this right here is the most important thing, which is the subdivisions might not always be equal. So notice here, 2 plus 1 equals 3, but 3 plus 2 equals 5. 5 plus 4 equals 9. 9 plus 1, 10 plus 3, 13 plus 1, 14 plus 5. They're not equally spaced. So that common height of our trapezoid that we usually pull on the outside, we're not going to be able to do that this time. Okay, so here's what happens. The heights are not all equal. So, and it'll tell you, use the trapezoidal rule. Is this out of the book? No, I'm using this. So, approximate the area bounded by f of x, the x-axis, and x equals 2 and x equals 19 using the trapezoidal rule. And you'll notice all these y values are positive, so it's above the x-axis. Okay? It'll tell you to use the trapezoidal rule with n equals 7, and you'll notice there's 1, 2, 3, 4, 5, 6, 7 different intervals to approximate the area. Okay, so that's going to be 1/2, but unfortunately we don't have a common height we can pull on the outside. So our height 1 was 1, our height 2 is 2, our height 3 is 4, height 4 is 1, height 5 is 3, height 6 is 1, height 7 is 5. So there's the 1, the 2, the 4, etc. And then you'll have base 1 plus base 2, which is f2 plus f3. The next one will be f of 3 plus f of 5. The next one will be f of 5 plus f of 9, etc. And you'll just take all those numbers from the table